All right, ladies and gentlemen, 5-5, similar figures, chapter 5, lesson 5. We have some vocab to start off. The first vocab word is similar figures. Similar figures would be figures with the same shape, but not necessarily the same size. They could be the same size, but then you'd have the exact same copy of a shape if they had the same dimensions, the same measurements. But a similar figure is usually going to have the same shape, but will be a different size. And we'll talk about what makes them similar here briefly. Corresponding angles or sides, I'm referring to both here with this definition. A corresponding angle or a corresponding side would be a pair of matching sides or a pair of matching angles that are in the same spot on two different shapes. The shapes must be the exact same shape, but it does not have to be the exact same size shape. Again, you'll come back and we'll talk about corresponding. 3 is a congruent angle, angles with equal measures. So if you have a right triangle and you have a second right triangle, you would say that the 90-degree measurement would be congruent on both triangles. And then a very, very helpful hint, or a very, very important rule for you to know is number 4. For 2 polygons, and if you skip down to number 5, we defined polygons as a shape with straight sides. So when we're talking about a polygon, we're talking about something that is a closed shape with straight sides, such as a triangle, a rectangle, a square. Hi, Linnea. We'll be with you in a little bit. I'm in the middle of a video here. Anyways, I'd say the rule here for number 4 would be for 2 polygons to be similar, corresponding angles must be congruent, so they must be equal. And corresponding means they're in the same position on that shape. And corresponding sides, again, in the same position on that shape, must have lengths that form equivalent ratios or form proportions or equal proportions. A polygon is a shape with straight sides. We already said that. 6, a couple of symbols for 6 and 7 anyways. A squiggly line all by itself means that you have a symbol for similar. And then a squiggly line over top of an equal sign means you have a symbol for congruent. Number 8, are the following rectangles similar? Why are they similar? Why are they not similar? So going back and using what you know about the definitions and also on how to check for something to be proportionate or sides to be proportionate from our last lesson, we're going to determine if rectangle J is similar to rectangle K is similar to rectangle L. So we're going to start just by comparing 2, and we'll start with rectangle J, and we'll start with rectangle K. You can see that the side length, the longer side length of the rectangle J is a measure of 10 units, and in rectangle K, the longer side length is 5. Those are congruent sides because they are on the same side on the shape, even though the shape is a different size. The bottom measurement for rectangle J is 4. The bottom measurement for rectangle K is 2. Again, the sides are congruent. We're not even going to focus on congruent angles because we can tell that all 3 of these shapes are rectangles, and as you know, rectangles all have 4 90-degree angles. So to check to see if rectangle J and rectangle K are congruent, we're going to set up ratios. So for rectangle J, we're going to take the long side 10 and put it over top of the short side 4. And then we are going to check for proportionality and see if rectangle K is proportionate to rectangle J by setting up congruent sides in our fraction. You know that you can check for equal ratios by cross multiplying. In this case, we got 4 times 5 is 20. 10 times 2 is also 20. And we now know that rectangle J and rectangle K would be proportionate. The next is to look at rectangle L. Rectangle L has measurements of, which got deleted, 12 and 5. And we know that if rectangle J is proportionate to rectangle L, that rectangle K would be proportionate to rectangle L because rectangle J and rectangle K are proportionate. So same thing, I'm going to use rectangle J and I'm going to compare it to rectangle L by matching up congruent sides. So rectangle J has a measurement of 10 for the long side, a measurement of 4 for the short side, and we're going to see if it's proportionate to rectangle L, which has 12 for its long side and 5 for its short side. Cross products, 4 times 12 is 48. Cross products, 10 times 5 is 50. They don't match up. Therefore, we know that rectangle L is not proportionate to rectangle J, and therefore the only two rectangles proportionate or similar would be rectangle J and rectangle J. So rectangle J is similar to rectangle K. Number 9, a similar problem. We are comparing triangle ABC to triangle DEF. ABC is a 30, 60, 90 right triangle, and triangle DEF is a 30, 60, 90 right triangle, so we know that the angles are congruent. Our job is to figure out if the sides are similar, if we can have proportion, or if we can form proportions. So I'm going to take the side length AB, I'm going to put it over side length BC for my first test, and I'm going to compare it to side length DE right here to side length EF, because they are in congruent positions, at least those measurements are. And I'm going to cross multiply. I get 40. I'm going to cross multiply. I get 40, and I know that those two sides match up. I'm going to check another area. I'll take side length AB as 12 and side length BC as 8 and compare it to the sides that are congruent in my second triangle. So DF, which is 6, and EF, which is 4. Cross products, I get 48. I get 48. And I'm going to tell you that the third side works as well. And therefore, I know that triangle ABC is congruent to or is similar. Triangle ABC is similar to triangle DEF. We will do scale factor on. We will not do scale factor with this lesson. So the lesson is going to end right here.